In just the first couple of months of this year, the world of quantum physics has been, well, it's been completely turned on its head. We're talking about 4 incredible breakthroughs that are already starting to reshape our future, and we're going to dive right into what they all mean.
It all kicks off with this image right here, which, yeah, it looks like something straight out of science fiction. But what you're actually seeing is a real glimpse into the quantum vacuum, what we all thought of as just empty space. Well, scientists have now directly observed particles literally popping into existence from nothing, proving a theory that's been around for ages, and honestly unlocking a whole new way of looking at reality itself. This isn't a someday thing. This is happening right now.
So, here's how we're going to break it all down. First, we'll look at why 2026 is turning out to be such a massive tipping point. Then, we'll get into 2 discoveries that are basically rewriting the rulebook on matter. After that, we'll see how scientists are using this knowledge to engineer things that were once thought impossible. And finally, we'll pull it all together and see what this new quantum age is really all about.
All right, let's jump into section 1. Quantum's 2026 tipping point. Why is the beginning of this year the moment everything started to change?
The thing you have to understand is just the incredible speed of it all. I mean, we're just a few months into the year, and we're seeing this amazing cluster of major breakthroughs, one after another. And this isn't just about making faster computers. This kind of rapid progress is going to have a huge ripple effect on everything from American artificial intelligence to our national security. So that brings us to section 2, rewriting the rules of matter. We're about to dig into some discoveries that really challenge how we thought the universe worked. And in the process, they're solving some really old mysteries. Okay, first up, researchers at Rice University and TU Wien over in Austria found something just wild, a totally new quantum state of matter. And the best part? Physics, as we knew it, told us it shouldn't even exist.
So how is this even possible? Well, they found a way to merge 2 ideas that everyone thought were totally incompatible. On one hand, you have quantum criticality. Just picture electrons perfectly balanced, like they're teetering on a knife's edge, about to fall into one state or another. On the other hand, you have electronic topology. This is where those same electrons are flowing in these super organized, protected patterns, kind of like cars on a perfectly designed highway. Scientists just found a material where electrons are doing both of those things at the exact same time.
And what's really fascinating is where they found this. This whole weird phenomenon was spotted in what are called heavy fermion materials. It's a great name because in these materials, all these complex quantum interactions make electrons act as if they are hundreds of times heavier than they really are. So, why should you care? Well, this discovery is a launch pad. It could mean more stable, more efficient quantum computers. It could give us ultra-sensitive sensors for everything from medical imaging to geology. And for sure, it gives a major boost to US innovation in a field that is absolutely critical for our tech independence. Now, finding a new state of matter like this makes us go back and look at old puzzles. And one of the biggest ones was always this. If you've got particles that are basically frozen solid with almost zero movement, how in the world can they create any kind of action or effect in a system? And the answer, which a team at Heidelberg University just cracked, is something called quasiparticles. It turns out these frozen particles aren't acting alone. It's their collective behavior. Think of it like a synchronized quantum dance that gives birth to these brand new entities, these quasi-particles that can then carry energy and information. So it's not the individual dancer, it's the whole coordinated performance that creates the action. The ripple effects from this are just huge. I mean, understanding quasi-particles is the key to unlocking true superconductors. That could lead to a US power grid with basically zero energy loss. Think about that for a second. It's a massive leap for clean energy. And on top of that, it's the foundation for the next generation of unbelievably fast electronics. Okay, so we've rewritten some of the fundamental rules of the universe. What's the next step? Well, you use that new knowledge to build things people used to say were impossible. Let's move on to section 3, engineering the impossible. You might want to sit down for this one. A research team in Germany just pulled off a world first. They built a quantum circuit component using only lasers. That's right, no wires, no metal, no electricity.
I know, it sounds like straight up magic, but the way they do it is actually pretty elegant. You start with a cloud of atoms, and you cool them down to almost absolute zero. Then, you use these super focused laser beams to literally draw a circuit path right through that cloud of atoms. And just like that, an atomic version of a super important electronic component just appears.
What you're looking at here is the result of that process, a perfect recreation of something called a Josephson junction.
Now that's a vital building block for every quantum computer and superconductor out there. And this team made one using nothing but light and atoms. It's an absolutely incredible feat of quantum engineering.
This is a total game changer, especially for American tech companies like IBM and Google, who are all in this massive race to build a working quantum computer. This new method could let them build powerful quantum simulators for stuff like discovering new drugs or modeling climate change. And, maybe most importantly, it could finally solve the single biggest problem in the entire field, keeping those fragile qubits stable.
Okay, now for our last breakthrough. We're moving from controlling matter to watching its very creation. And to get it, we have to talk about the quantum vacuum. See, in the physics we learned in school, a vacuum is just empty space, right? Nothing there. But in quantum physics, empty space is actually this chaotic soup, teeming with these virtual particles that are constantly bubbling into and out of existence.
And that brings us to this really profound discovery from Brookhaven National Lab. By figuring out how to watch this quantum vacuum, they're getting to the very heart of one of the biggest questions there is. How does matter arise from nothingness?
By actually seeing particles emerge from the vacuum, scientists are getting clues about how the universe itself was born. But the real-world applications are just as exciting. This research could lead to better, more advanced particle accelerators for cancer therapy, and it can help us design brand new materials for American manufacturing.
So, let's pull all these threads together. In our final section, we're going to look at what it means to be standing at the dawn of a new quantum age. What does all of this actually mean for us?
Here's the most important takeaway. These 4 discoveries, they're not just random, isolated things for scientists in a lab. From rewriting the rules of matter to literally engineering the impossible, they are all powerful, connected signs that we are at a major tipping point. We're finally moving from quantum theory to quantum reality.
So what does that new reality look like? Well, it looks like artificial intelligence that's exponentially faster than anything we have today. It means unbreakable encryption, a whole new world for security. It means a completely revolutionized hyper-efficient energy grid, and it means next-generation medicines and materials that, right now, we can barely even begin to imagine.
This isn't science fiction anymore. As all these breakthroughs prove, the quantum age isn't some far-off dream. It's arriving right now, as we speak. So the only question left is the most exciting one of all. What are we going to build with it?